My name is Mathieu Stoll. I'm the heat pump expert at Danfoss. Just a brief introduction. I've been in the HVAC industry for the last 20 years now. Started at Train as a system laboratory leader. And 13 years ago, I moved to Danfoss as a variable speed scroll application specialist. Few years later, I moved to the position of marketing and strategy director for the scroll product lines for air conditioning and heat pump application. And since the last 3 years, I moved to a new team that operates across all of the division and product lines of Danfoss Climate Solution as the heat pump expert and system engineering leader. So basically, I'm supporting OEMs into their heat pump projects, and I'm also supporting our various product lines in the development of components for heat pumps. Basically, system expert, design expert, and regulation and standard expert. So today, I want to talk to you about our solution for water-to-water heat pump or ground source heat pump with a refrigerant charge below 150 grams, obviously with propane. So a bit of context. I'm not going to go into details. This is pretty well known by everyone now. But with the F-gas regulation, we are now phase down of HFCs, and we have various product bans that are targeting the heat pump sector. In short, what it means is in a few years from now, we will need to use refrigerants with GWP below 150 and most likely natural refrigerant. So this is bringing propane as the one solution to the front of the scene. Of course, there still are A2L alternatives of low GWP like R-455A, R-454C. But yeah, you all know those are blends with a high YF content. Who knows what will happen with the REACH regulation in a few years from now. So basically, precautionary dictates to use propane whenever, wherever it can be used. Simply, it's the great refrigerant, best thermodynamical properties, except for the high flammability. So not all applications are born equal when it comes to propane and flammable refrigerant. Obviously, it is much more of a constraint for direct expansion system or even monoblock system that are sitting indoor. So the path is pretty simple for air-to-water monoblock, and this is why you see all of those propane systems out there. But okay, today we want to talk about those systems here that are also quite important. The brine water, water, monoblock system, ground source heat pumps, they have many names. And those type of systems, they are typically installed indoor. So leakage here can be an issue. So because of that, when we look at the safety standards, we can see that, so we are fine up to 150 grams, but then above, we have to use one of these options here, either go to a ventilated enclosure. This is probably the options that will be adopted the most. Alternatively, the system could be redesigned to be placed outdoors, but who really wants to do that? That means using glycol on the indoor loop with all the drawbacks that it has. Or the A2L alternatives that I mentioned before, but those may very well be short-lived. For larger system, okay, machinery room can be available, and we have a nice alternative with 1234Z. But okay, so today, this is about the small heat pumps for residential application, single family or maybe multi-family use as an apartment booster in an ambient loop setup or in a brand new 5G district heating network. But okay, this can be still some years away. So if we want to be free of constraints, we have to keep the charge below 150 grams. And this is quite a challenge. So to achieve that, the first thing we need to do is we need to squeeze the internal volume of the system as much as possible. So what do we need to do here? We need short and small piping diameters. we need very compact line components, as compact as possible. And a good idea is to relocate the filter dryer to the suction side. With the drawbacks that it brings, you need to pay attention to the pressure drop that would otherwise impact your performance. Super important is your heat exchanger selection. Here you want a heat exchanger that has been designed for the job. You want a high press depth so that you have low free volume in between the plates. You want high heat transfer so you don't need to use so many plates in the heat exchanger. And Danfoss has some new heat exchanger that are really perfect for that job. I'll come back to that later. Basically, we have this model here that can be used as an evaporator. You would also use it as a condenser if the water-to-water system is reversible. Now, if it's a heating-only system, we have this exchanger here that is only intended to work as a condenser, but that will even help to further reduce the charge. Very important also is the compressor. And this is something that maybe comes unexpected for people who haven't started looking at this. But in reality, a lot of refrigerant gets trapped into the oil of the compressor. I'll show you a pie chart a bit later. It's much more than what that one would expect. So basically, we need a compressor that has a minimum oil charge, as low as possible. We cannot go too low because then we also risk to impact the reliability of the compressor. So we have to find the right trade-off. Hopefully in such applications, it's not like an air-to-water system where you have defrost, etc. So on a ground source heat pump, you can safely reduce the charge a little, but only up to a certain extent. Then the oil type is very important here. So you have the most common oil that's being used in AC is typically the POE oil. This is not the best when it comes to dilution of propane. So here you want to look at PAG oil. So you need to find specific compressor that have been qualified with this type of oil. Then we have different types of compressor designs. So you have the European type of design, which we call low side. Typically, all of the scrolls you can find from Danfoss or Copeland or Bitzer. Those are low side design, meaning the whole shell is at the low pressure. This helps with lower dilution. And then we have high side compressor. So those are typically the Asian design, so scrolls from Asia or rotary compressor. The whole shell is at the high pressure. This doesn't necessarily help. Obviously, you also want a compressor that has minimal free volume. So at Danfoss, we have access to identify the specific rotary compressor that meets most of those criteria. Obviously, it's still a high-side compressor, but still it's the best compromise that can be found in the market. Coming back to the heat exchanger. So this is our propane microplate heat exchanger lineup, optimized for heat pumps. We offer 4 options with varying cost, performance, compactness, refrigerant charge, and ease of compliance to safety standards. We have various options, and we have to identify the one that will meet your needs the most. So, first option is the typical single-wall heat exchanger. Those imply the use of a deaerator to comply with the safety standard in case a leak occurs and refrigerant flows into the water circuit. Got 2 models for residential here, 2 models for light commercial application, multifamily. One is typical single heat exchanger, and this is a dual for a double circuit system. The residential products here come in 2 variants. We have a standard variant and a low charge variant. That obviously is going to be of interest to us into this project. Then we've got double wall heat exchanger. So double wall means that we have an empty channel in between the refrigerant and the water channel. This has for effect that in case of a leak, the refrigerant would directly flow through this empty channel and be expelled outside. The interest of this heat exchanger is you do not need a deaerator to comply to the safety standard. So basically, it's a value proposition, up to every OEM to define what's the best choice for him. You either have the double wall, which comes with a bit of an extra cost, and you compare that to the single wall that is maybe more cost optimized, but you have to also factor in the cost of this deaerator here. Typically, in residential applications, 30 to 50 euro. So yeah, for this reason, we call this compliance made easy, this type of products. And then finally, we have this new type of heat exchanger that come with a mixing chamber. So I'm not going to go into the technical details. They are again single wall, so they need again the deaerator. But the beauty of those heat exchanger is they offer a best compromise in terms of performance and cost between a true evaporator that is equipped with a distributor and a much simpler condenser design. So if you ask me, this is the ideal heat exchanger for a reversible system, and in particular, a reversible water-to-water system. Now, compressors. So I already listed all the key characteristics of the ideal compressor, and this is the one that we are using in this project. So it's a specific rotary compressor. You may know that Danfoss offers a rotary compressor for the residential market. Those are the typical, it doesn't show here the range, but we offer the typical range of rotary compressor from 4 to say 20 kilowatts. But those are not suited when you want to design a low charge water heat pumps. So we have had access now to this compressor here. It's similar, making a comparison here with the smallest compressor for typical air to water applications. So you can see similar sweat volume, meaning similar capacity. It's using PAG oil, so that's beneficial compared to traditional POE. And the oil quantity in the compressor is 3 times less as the standard compressor. So I was saying earlier, this may come as a surprise. This is the refrigerant distribution in a system. So you have obviously a high content into both heat exchangers, but just as much is into the compressor. So part is in the free volume, and the rest is what is trapped into the oil. So this is far from being negligible. So here, this is what if we compare the different types of oil. So here, this is purely the solubility curves of the POE oil, and here the PAG oil. What you can see already is you have twice as less dilution in PAG oil. Now, if you compare compressor and you factor in the oil quantity of this compressor, we are talking 3 to 4 times less refrigerant trapped into the compressor. So that's just so much more opportunity you have to have useful refrigerant into your system. So this project started with a simulation exercise. So here you have the system that has been simulated. We are using D-molar here. You have all of the key characteristics. To be noted that the internal free volume of what we simulated is 2.645 liters. And this is what we actually assembled. So what we assembled is significantly more compact. At the end of the day, we had a 24% reduction of internal volume. To be noted also that what we assembled had no filter dryer, which is something that can be discussed and questioned. On a new system coming out of a factory, very compact water system, do we really need a filter dryer? It's not guaranteed. After a service operation in the field, then okay, we definitely need a filter dryer. This is our the bill of material that we are using. You can see that I'm hiding the specific model number. You only have the range number. If that's of interest to you, I'd rather you come and talk to me than you try and approach your typical sales contact. So this is the outcome of it. So you can see here the system, really, really small. Actually much smaller than the control, the electronic box that we designed for it. Now, of course, this is in a lab environment. This has not been optimized whatsoever. You have the happy project team here, a familiar face right here. So this compressor comes packaged with its own inverter. So you can see it here. The brand new Danfoss controller. On this side here, you can see we use this project also to validate the new quick connector we are using. So this is a new type of connector, doesn't require brazing operation, can be interesting. We use new sensor blocks to combine pressure sensor, pressure switch, temperature sensor, and also service valve. This is a four-way valve. Huh? So here we are making a reversible system, which is, in other words, conservative, because if the system was a heating-only system, we would have much less piping, no four-way valve. So this is a harder challenge. The compressor here, the two heat exchangers. So as I said, this was a reversible system. So we picked the heat exchanger with the mixing chamber and on fairly new and very compact ETS5M electronic expansion valve. This is how it looks compared to a 1.5 liter water bottle. It's a very small unit. You have the dimensions here of the, let's say, the thermodynamic assembly. Of course, this at the end at an OEM needs to be packaged into a box, so dimensions will be higher than this. And here doesn't include any electronics. The outcome of the simulation exercise, super interesting slide, but very technical, so I'll spare you the details. Just look at the conclusion here. So it's the typical charge optimization curves, but the result is it showed that for this system, the optimal charge lands on 158 grams. But remember, what was simulated at a higher internal volume than what we actually assembled and tested. This is the charge optimization achieved in reality. Okay, yeah, just one comment. The charge optimization was not done at full speed. I won't go into the reason why this was done like this, but it doesn't matter because that's conservative. If we had done the charge optimization at maximum speed, the optimal charge would have resulted in a slightly lower charge. So no problem. Typical charge optimization curve, we look for the high capacity point, the high COP point. We land on a subcooling here of 7. This is typically what you want to look at, between 5 and 7. So yeah, why we had this? So, and here, the optimal charge, the good news here, it's only 130 grams. So remember, this is a reversible system. It has not been optimized at the right speed. So yeah, it's quite conservative. So why do we have this discrepancy with the simulations? Mentioned it before, tested internal volume is lower. And of course, the Dimola model is, okay, perfect at predicting charge in components or that have single-phase refrigerant, but in heat exchanger, evaporator, and condenser, here we have two phases. It's much more complex to predict. So to us, there is 20 to 30% uncertainty into this Dimola model, but at least the trend matched very well. Some performance that we achieved. Okay, unfortunately, I do not have a full SCOP. This is probably what you're looking at. We tested both. So in blue here, you have the low temperature regime, in orange, red, the medium temperature. We have some of the key points, the E points -10. I'm talking brine to water here, but the E point, the A point, the C point, very important part load here, and an aerotherm used just in case. So you can see those values are more than reasonable. They are fairly good. I don't have a SCOP, but I can guarantee you can meet A++ with this easily. And A3+ might be a little challenging, but we have some margin. We can further increase the number of places of the heat exchanger. So I'm super confident A3+ can be achieved. Cooling performance, also very decent. I'm seeing the time fly by, so I'm going straight to the final slide. So what's to remember here? So we achieved 130 grams of propane in this system. We have quite some potential for optimization. If it's optimized at the right speed, we have 20 gram margin. We can increase the number of plates. And obviously, this was not a complete design. So there was no insulation on the compressor, no insulation on the pipe. And we know this is very important, especially with high side compressors. So again, could increase COP by 5% just by doing so. How does it compare to other products? So if you look at the heat pump key mark, there is only one stench unit that's been certified there for a few years. Of course, when it was designed, it didn't have access to all of the good components that we now have, but we beat it by far in terms of performance and charge. And now I also have to give credit to the former research project that have been done on this topic. We've got the very famous Fraunhofer Institute that take a good look at it, paved the way for the industry to believe that this was achievable. CETIAT in France also took a look at that. And yeah, what I can say is we are able to exceed, at least find a better compromise. Now, if you look at Fraunhofer, they tested tons of configuration, but we have a better compromise here. So for you guys OEM, we have a bill of material ready that is qualified. I can guarantee you the charge. I can guarantee you the performance. Now your job is simply to design the whole system, the assembly, take a look at vibration, insulation to get a decent noise level results. And I'm just going to stop here, open for questions if you have. Otherwise, just contact Danfoss and we'll be happy to discuss that at length with you guys.